What's up, gents? Today we're taking an old discarded motorcycle chain and turning it into a razor-sharp tactical recurve blade. First step, throwing it into a glass dish and drowning it in liquid solvent because it's caked in years of old grease and road grit. Let's scrub it down. Once the chain is semi-clean and dried off, we fold it into a tight, neat little rectangular block. This layout is going to be the core of our custom Damascus billet. If you're into the chaos to precision process, stick around and subscribe. Now we break out the arc welder to tack all these loose links together so they don't shift around. I also weld a solid piece of rebar on the end to act as our forging handle. Then it goes straight into the brick coal forge. Throw in some fuel, pump the air, and watch it roar. We need to get this block up to a bright orange heat. Sparks are flying everywhere, which means it's working. I pull it out for a quick inspection, hit it with a hand hammer, and immediately sprinkle it with white borax flux. Back into the fire to reach full forge welding temperature, roughly 2300 degrees Fahrenheit. Once it's glowing yellow, we bring it to the anvil and start hammering manually to crush those open gaps and force the independent links into a single solid mass. Time to bring out the big guns, the mechanical power hammer. This machine does the real heavy lifting, flattening out our stacked chain billet under massive vertical pressure. This high-impact squishing ensures all the internal voids and pockets are completely gone. We keep flipping the billet 90 degrees to squeeze it from all sides. It's a loud, hot process, but watching the chain pattern compress tightly into a solid piece of tool steel is incredibly satisfying to watch. Let the bar cool down completely on the anvil so we can work with it safely. Next, we use the massive abrasive chop saw to clean up the uneven, rough edges. Then, it's secured tightly in the bench vise, and we use an angle grinder to clean off all that nasty black scale from the flats. We need more layers for a tighter pattern, so I grab the tape measure and mark out equal segments with a marker. We stack those clean plates directly on top of each other to multiply our pattern layer count and arc weld the edges together. This creates a high-density laminate block. Back into the coal forge, it goes for another intense high-temperature heating cycle. Pulling it out yellow-hot, we give it a quick wire brush to remove surface debris, hand hammer the edges, and apply a fresh coat of borax flux. If you skip the flux at this stage, trapped scale inclusions will completely ruin the structural integrity of your finished blade. Back into the roaring fire to bring the new stack up to fusing temperature. Once it's ready, the power hammer takes over again, drawing out the multi-layered block into a long, consolidated bar that will actually fit the scale of our planned knife template. We use the power hammer dies to step down the thickness, thinning out the front section that will become the blade while leaving the tang a bit thicker for balance. It requires careful control under the heavy blows so you don't over-thin the cutting edge. Now we move back to the anvil for the fine hand forging. I hammer the tip down against the anvil face to start creating the clip point profile and the aggressive recurve belly line. A quick reheat, and we work the glowing blade over the horn of the anvil to refine that inner recurve radius. After checking it visually for absolute straightness along the spine, we let it air cool. Here is our rough forged monster blade profile, ready for the grinders. Lock the cooled blank securely into the heavy vise. We use an angle grinder fitted with a grinding disc to clean up the perimeter, squaring off the flat spine and refining the exact sweep of our cutting edge according to the intended design shape. Now for the messy part, rough grinding the primary bevels. Sparks are putting on a massive show while I establish the plunge lines and grind a clean, uniform taper toward the edge. Keep a steady hand here, or your grind lines will look completely wonky. We use the chop saw to cut the blade free from our rebar forging handle. Then we head over to the disc sander to clean up the profile of the full tang handle area, smoothing out the tight transitions and removing any sharp metal burrs. Next up, we lock the blade down to bore out a lanyard hole on the press. Once the drill punches through, I switch over to a rotary carbide burr tool to cleanly chamfer the inside edges. Time to polish out those ugly, grinding scratches. We throw some water on the blade and use a hard backing block with fine grit sandpaper, manually working down the flats until we get a uniform, clean satin finish across both sides of the steel. The blade goes back into the coal forge for the most critical step, heat treatment. Once it hits critical non-magnetic temperature, we bring it out and plunge it straight into a vat of engine oil to quench it. Look at that glorious white smoke rise up. After letting the blade cool down, we pull it out of the bucket and brush off all that loose carbon scale. Now comes the real punishment, manual hand sanding. I drench the steel in some soapy water and go to town with a hard backing block to clean up the flats and erase all that ugly quench residue. It's an absolute thumb killer, but skipping this step means our final acid etch will look like total garbage. We do some serious elbow grease work here, cleaning up the tang and refining the blade finish. It takes time, but a flawless surface preparation is absolutely essential if you want the high-contrast Damascus pattern to pop beautifully later. We finish up the blade flats, wipe away all the dirty slurry, and check the blade for straightness. It survived the quench without warping or cracking, which means our heat treat cycle was spot on, and the internal stresses are balanced. Now for the magic. We set up a vertical container and fill it with ferric chloride acid. This chemical etches the different steel alloys within the chain links at different rates, revealing the hidden motorcycle chain pattern beneath the surface. We submerge the blade, let it sit, and pull it out. A quick spray with a neutralizing agent stops the acid from eating the steel further. Look at that incredible high contrast and wavy texture created by the old chain links. To give this tactical beast a proper handle, I protect the sharp edge with white tape and begin an intricate wrap using heavy-duty green paracord line. We cross the lines over the tang very tightly to ensure a rock-solid, slip-resistant grip. We continue weaving the paracord pattern all the way down the handle tang, pulling each loop as tight as humanly possible. At the end, we thread the remaining cord tails through our drilled lanyard hole to start the terminal knot assembly. We braid the remaining cord tails into a thick decorative lanyard bead knot, adding a nice tactical accent that also helps you pull the knife quickly. Double-check everything is perfectly aligned and tight before finalizing. Let's see if this thing actually cuts. It effortlessly slices through sheets of paper ribbons like an absolute laser beam. And just to prove how ridiculous this edge is, it shaves the hair clean off my forearm with zero resistance. For the grand finale, a clean, lightning-fast slice right through a freestanding plastic water bottle without even knocking it over. If you enjoyed watching this junk chain turn into a masterpiece, hit that subscribe button, drop a comment, and I'll see you in the next project. Today we are taking a bunch of ordinary ribbed construction rebar steel and turning it into a custom tactical chopper knife. Because why buy high-grade tool steel when you can spend hours salvaging junk metal? If you're into turning scrap into this, hit that subscribe button and stick around. We do this kind of questionable engineering all the time. Into the gas forge it goes to reach a bright orange heat. Now for the fun part, creating our core pattern. We clamp the hot billet into the massive shop vise, grab a heavy-duty twisting wrench, and twist it like it owes us money. Twisting the rebar like this creates beautiful alternating lines that will look absolute killer once we etch the final blade later on. Next, we slap on some protective flux paste, give it a quick reheat, and clamp it straight into the heavy shop vise. Now we grab our massive twisting wrench and crank this glowing steel like a giant pretzel. This heavy twist is exactly what gives our final Damascus steel those crazy, beautiful pattern lines later on. Once it's up to a uniform forge welding temperature, we take it out and drop it right under the rapid mechanical power hammer to permanently seal the layers. We keep those heavy dies cycling, drawing the twisted billet out flatter and wider, while occasionally flipping it on its edge to keep our profile completely straight and parallel. My elbows are definitely thanking me for letting this machine do the heavy lifting today. Once the flat bar cools down, we lock it back into the vise. It's time to bust out the angle grinder to clean up the surface scale. We need to grind both sides down to completely clean, bright metal. If we leave any scale on here, it will cause nasty inclusions when we stack it up in the next phase. With the steel looking nice and shiny, I'm measuring it out with a tape measure and marking lines with a white marker. Then it's off to the abrasive chop saw to cut this flattened rebar into multiple equal plates. All right, we've got our clean-cut pieces. Now we are stacking them up alternatively with contrasting solid steel plates to create a high-contrast Damascus composite billet stack. Back into the belly of the beast. We bring the stacked billet up to a bright yellow forge welding temperature. I give it a quick initial set with a hand hammer on the anvil, then coat it with more borax powder to make sure the melted flux squeezes out any lingering impurities between the layers. Now let's unleash the mechanical power hammer. The rapid heavy blows consolidate the layered plates into a single solid piece of Damascus steel. We flip it, hammer the edges, and draw it out continuously into a long, flat knife billet. I'm using a white marker to draw out an aggressive, heavy-bellied chopper blade profile complete with a recurve and some spine serrations. Then, I grab the angle grinder with a cutting wheel to roughly slice out the shape. Now we take the rough blade profile to the heavy-duty drill press. I'm drilling precise pinholes through the handle tang area for our future scales. Next, we throw it onto the surface grinding machine with a magnetic chuck and a steady stream of liquid coolant to grind the blade flats perfectly uniform and parallel. With the flats ground to a clean precision shine, we move over to the industrial belt grinder. I'm using a coarse grit belt to rough out the blade geometry and profile the outer edges. This step is crucial for establishing clean plunge lines and setting up the symmetrical geometry of the primary bevels. I'm working the blade against the grinding platen, carefully establishing the primary bevels and cleaning up the deep finger choil area. I also make sure to run the spine along the wheel to prepare for the tooth detail. To refine those aggressive spine notches, we clamp the blade into the vise and use a high-speed rotary die grinder with a carbide burr bit. This lets us smoothly machine inside the curved notches, making them identical and removing any sharp grinding marks that could cause stress fractures later on. Next, I'm laying the blade flat and using a blue marker pen to map out exact grinding reference lines across the primary bevel area and along the edge center line. Then, I bring back the angle grinder with a heavy-duty grinding disc to carefully hog off the bulk material along those blue lines before the fine sanding. I spray it down with a bit of water lubricant and get to work with a sanding block for some old-school hand sanding to smooth out the surface scratches. After wiping off the metallic slurry, I'm using a small needle file to meticulously sharpen each individual serration tooth on the spine. Time for the magic science step, heat treatment. I'm placing the prepped blade into our electric heat treating kiln to bring it up to its critical temperature. Once it's glowing cherry red, we pull it out with tongs and immediately quench it into a tub of engine oil to harden the steel structure. Look at all that glorious smoke. After agitating it to prevent vapor blankets, we pull the blade out and inspect it for any warps. Luckily, it looks straight as an arrow. Now we hand sand it with a block to strip off all the black heat treat scale and expose the fresh, hardened steel surface for the acid bath. Now for the ultimate reveal. We submerge the clean blade into a container filled with ferric chloride acid. When we pull it out and neutralize it, boom! A stunning high-contrast Damascus pattern emerges from the rebar and plate steel mashup. To make that pattern pop even more, we take it to the high-speed cloth buffing wheel loaded with polishing compound. We are polishing the flats, the spine serrations, and the bevels, bringing the nickel layers up to a gorgeous mirror shine while keeping the darker etched layers deeply contrasted. The blade looks absolutely gorgeous. I'm wrapping it securely in tape and paper so I don't accidentally slice my thumbs off during the handle assembly. I've selected a beautiful piece of dark hardwood block material for our custom handle scales. Let's get these scaled out to match the tang. With the holes drilled, I use a blue pen to trace the outline of the tang onto the wood block. Then, I use the angle grinder with a cutting disc to rough cut the handle scale block, sawing off the unnecessary corners. Before gluing, we pin the two scales together and use the belt sander to grind and shape the front face of the handle. It's way easier to shape and polish this front section now, because once it's glued onto the blade, you won't be able to reach it without scratching your beautiful etch job. All right, time for assembly. I slide the brass pins through, tap them flush with a hammer, and lock the entire handle into the vise to cure fully. Let's clamp the blade back in the vise. I'm using an angle grinder equipped with a coarse flap disc to rough shape the wood scales and grind the extended brass pins completely flush with the profile of the handle. Watch the wood dust fly. Now we move over to the vertical belt sander for the fine contouring. I'm using the small wheel attachment to perfectly shape the finger grooves and ergonomics, ensuring a rock-solid grip. Then I use a slack belt setup to round off all the sharp corners into a smooth, comfortable handle. To finish off the handle, we bring it to the cloth buffing wheel. We buff the wood to bring out its rich grain color and polish those brass pins to a brilliant gold shine. And there it is, fellas. From construction rebar to a wicked custom Damascus chopper knife. Let's give it a quick paper slicing test to check the edge. Slides through like an absolute dream, cutting perfect, effortless curves. Make sure to smash that subscribe button, leave a comment down below on what piece of scrap metal we should forge next, and I'll catch you guys in the next video.